internal rate of return. So as I mentioned, NPV was the most important one for all of this chapter actually. And the internal rate of return, or IRR, is the second most common criteria for investing, is the second most important as well. If you look at any kind of business plans, if you look at, I like to look at a lot of details of quarterly and annual reports of gold miners and stuff like that. So all of them do bring examples of NPV and internal rates of return, how much value is this new mine is going to generate once we build the infrastructure around it, stuff like that. So IRR is the second most commonly used in business, second most important after NPV. Okay. So, and it's kind of same thing as NPV, to be honest. So remember with NPV formula, here's the NPV formula at the top. So here's the formula at the top for NPV, right? We calculate NPV by discounting all of the cash flows. Discount them, add them up, everything, even including the cash flow at zero, the negative one. Once we add up everything, including the cost, that gives us negative, net, after cost, net present value. And to find that, we need to insert some rate. Okay, and IRR is just the opposite. For NPV, we insert zero. We insert zero for NPV, and from that, we rearrange the formula to find this rate, the internal rate that the project will return, will give you. Okay, so that's basically the general idea, is how much rate the project is gonna generate for you. Is this factory in Japan gonna give you 8% return over the next few years? Or is it gonna give you 20% return over the next few years? Right? So it's actually same as looking at the same NPV formula, but rearranging it. For NPV, we put zero and calculate the rate instead. So if we have a simple example, right? Let's say something like in year zero, investment is negative $1,000, and it's only a one-year project. For example, the return is, let's say, $1,100. How much is the return in percentages? Anyone? How do you guys think? How much profit in percentages are you making in this one-year project?
10%.
10%, right? I mean, really, really easy. How did you get to it? Well, just divide this by this, right? So far, so good. So far, easy. With a 2-year example, it's getting a little bit kind of more difficult. Let's put like 5,500 here and 5,500 here. So it's still 1,100 over 2 years, but with interest on interest. We're going to calculate some details. It's still possible. It's going to be something like, if you really look at it mathematically, it's going to be something like ax squared plus bx plus c equals 0. Remember, guys, you had these quadratic equations in high school. I guess many of you guys had, right? I remember we calculate discriminant for that, plus minus b, what plus minus, oh no, yeah, plus minus b, no, b plus minus square root of whatever it is, I don't remember. It was a long time since I came out of high school, so I don't memorize the formulas. But for a 2-year investment, yeah, we can still do it by hand, although it already gets a bit difficult. But with a 3-year investment, with a 4-year investment, or even with a longer term investment, it's going to turn difficult really, really, really fast. Even with a 4-year investment, which is not that much longer than 2-year investment, this calculation turns into a much more difficult one. There's going to be cx into the power of 2 plus bcdx into the power of 1 plus abcde equals 0. How do we solve for this equation? That's much more difficult than a simple quadratic equation, right? Things get difficult really fast. So for anything more than 2-year project, For anything more than 2 period projects, it's basically impossible to calculate by hand. Okay. So let's go to Excel. Let's go to Excel. And again, let's have some project. Your business is expected to generate the following cash flows. Okay, and let's say originally we need an investment of say 1,000. Maybe that's already in millions, so that's $1 billion for a business, whatever. And let's have some numbers here. A bit strange, but okay, let's say this is the projection. Okay, and minimum required return is, let's call it 18%. Let's say we have a few questions here. Let's say we have to calculate both NPV and internal rate of return, as well as decide whether we accept or reject this project. Okay, we have everything we need for these. So let's start doing that. NPV is very easy. You already know how to do it. Equals NPV. Open the brackets, enter the rate, and enter the values only starting from value 1. Close the brackets. Don't forget to add the original investment. NPV is negative. Oh my God, looks like we should reject the project. Let's see what IRR says. So let's calculate IRR. For IRR, it's very simple. Equals IRR. In Excel, things are simple. Open the brackets. What does it say? Just values. Just values. Oh, so easy. Guess. It doesn't matter. Forget about the guess or whatever. Don't give your guesses to the computer. It doesn't need it. Close the brackets. Enter. That's all. Let's see some details. Because 1.38% is not equal to 1%, I do want some details on the exams. Okay. There, so IRR is 1.38%. The first two questions already answered. Third question, do we accept or reject? According to NPV, it's negative, so we reject according to NPV. According to IRR, what do we do about IRR? The decision rule for IRR is accept only if IRR is greater than the minimum required return. Okay, so in that case, it's going to give us the same answer for accept or reject as NPV, because we put the minimum required return into the NPV calculation to find whether it's positive or negative. But for IRR, we put NPV 0 and then compare the resulting percent with this. If it's smaller, then reject. If it's bigger, then accept. If it's equal, if this is equal, then NPV is going to show us 0. Then we're not making any money with this project. Yeah, we're not losing any money, but we're not making any money, so we don't accept either. Okay. Accept because NPV is greater than 0, and I'm sorry, reject, yes. Reject because NPV is less than 0 and IRR is less than the required return. So for IRR, we don't need the required return for the calculations. We need the required return for IRR to make a decision whether we accept or reject. So lastly, let's go back to the slides to finish up with IRR. Okay. So as I said, without the calculator, once you go for more than 2 periods, it gets really difficult. Even with 2 periods, I'll have to Google up the formulas how to solve that quadratic equation. Should be easy enough, takes 10 minutes. But still, anything more than 2 periods is getting really hard. Okay. And Excel, very easy. You just need the values themselves, including the original value. Then you have to manually compare with the required return. Okay, so we have looked at NPV last week, and we've looked at a couple of other criteria to evaluate longer-term investments, capital budgeting investments, such as payback period, average accounting return, and we finished with the internal rate of return, IRR. And it's actually very similar to NPV. It's actually very similar to NPV. We use the same formula, we just rearrange it a little bit. We don't actually work with the formula. The computer helps you quite a lot. The computer just basically does the job for you. You just need to understand the question and know what's required of you. As I mentioned many times, in the modern world, in the 21st century, you don't even need to memorize all of these formulas. You need to be able to use your brain to understand what's asked of you. You don't need to memorize all of these tricky formulas. You can always access them on the internet, but you really need to understand what you're talking about, right? So with that in mind, let's have an understanding of this formula for IRR so that we know what it's about, even though you're not going to use this formula by hand. Okay, so for NPV, we basically just discount all the future cash flows. And we discount all the future cash flows according to the required rate of return appropriate for the level of risk. If the risk is higher with a given project, we just apply a higher required rate of return, because for you to invest into a more risky investment, you'd only invest if the return is greater. So your requirement for that return, required rate of return, is greater. We discount all the future cash flows at a given required rate of return and find NPV. If it's positive, the project is going to make you money, so you invest. For IRR, we just do the opposite. Make NPV 0 and find what's the return inside that project. So internal rate of return. Then compare this internal rate of return with your required rate of return. If IRR is bigger, then invest, otherwise don't. So it basically shows you the same picture. It really does show you the same picture, but from a different perspective. It's just a different side of the same coin. So, calculating IRR, very easy process. Open Excel file, hit equals, type IRR, open the brackets, you get all the hints. So let's have an example. Very easy. Years, cash flows, let's say, and let's say we have our required rate of return. 0, 1, 2, 3, and whatever it is. Say you are building some factory, it's going to last you 12 years. It's going to take you 120 million first to build the factory, and after that it's going to generate some money, starting with some small money, 1 million, 2 or 3 million, and after that perhaps more millions, like that. And let's say the required rate of return, let's say it's a relatively low risk investment, it's a local investment, you're going to control everything. Let's say your required rate of return is only 7%. Let's calculate IRR here and answer whether we want to accept or reject the project. Equals IRR, open the brackets, enter the numbers, close the brackets, bam. Okay, so these numbers are too small. We don't even get 120 million back, yes? Okay, let's change the original investment. 55 million, IRR is 3%. I don't think it's actually 3%. What are the chances? It's perhaps 3 point something. So remember to give me the details, otherwise the answers are not going to be correct on the exam. 3.18 is not equal to 3. So if you enter 3 as your answer, that'll be wrong. So do we accept the project here or do we reject the project? How do you guys think? Anyone? Remember, we compare with the requirement to see if we accept or reject the project. How do you guys think? Accept or reject? So the project returns us, the project gives us, so the internal return is just over 3%. But for this level of risk, our requirement is at least 7%. So we reject. Let's write it down. Because IRR is less than the required rate of return. Okay, a bit confusing here. It's IRR and RRR. I'll use a triple R for the required rate of return. Now let's try to calculate NPV, just to see whether these two criteria will tell us the same thing about the project, whether we accept it or reject it. So equals NPV, open the brackets, very easy. The rate, comma, values starting from the first cash flow, not the zeros cash flow. So that's something that is easy to forget, actually. And another thing that's easy to forget is to add the original cost by hand. Enter, and the computer thinks it's in percentages, perhaps because we already have some percentages here. So let me cancel that. We just can go to, if you have a similar problem on your exam, you can just right click, go to format cells. So this project loses 13 million. But anyway, even a little bit of a loss, even just $10 loss, as long as it's negative, even if it's zero, why would we invest if we make $0? Okay, so this is our NPV, and again, reject because NPV is less than 0 or equal, or even like this, less or equal, equal or less than 0. Okay, so what's the connection between them two? What's the connection between them two? Well, if I change this interest rate, if I decrease this interest rate, NPV is going to improve. And at one point, NPV will turn positive, allowing me to accept the project. Same with internal rate of return. If I reduce the required rate of return, at one point it will become lower than the internal rate of return, allowing me to accept the project. So let's put that on a chart, internal rate of return, both rates here, and let's have NPV on the vertical axis. Now the thing is, right now NPV is negative when the required rate of return is 7. Actually, let's put some numbers there so you know where we are. So perhaps this is 0, that's 7, and this is rates. So when the rate is 7, NPV is actually negative. So NPV is somewhere around here into negative when the rates are 7. But if I keep decreasing the rates, if I keep going to the left, NPV is going to grow, right? NPV is going to improve, coming to some highest number whenever the rate is 0. Actually, I can tell you exactly how much is the NPV when the rate is 0. If the rate is 0, today's dollars are the same as tomorrow's dollars. Then I can just have a sum over here giving me NPV equal to 15 million. So this will actually be 15 million on NPV. Okay, that's if the rates are 0. So that's what actually called NPV profile. NPV profile. Okay, which is the relationship between NPV and required rate of return. Okay, so on the exam, I think it's not very likely that I will ask you descriptive questions like this. What is an NPV profile? But on the other hand, maybe I will. Especially because the exam is online anyway. I might have some additional multiple choice questions on Moodle. So yeah, take notes of whatever you can find useful. So this is called NPV profile. Okay, of course, it's a downward slope line. As the rates increase, NPV drops. And when we calculate NPV, what happens is we choose a required rate of return. Let's change this number here. Let's choose 2% here, or 2.2%, for example. Let's show some details. 2.2%. NPV, as you see, has increased to 4 million. So what we do when we calculate NPV is we just choose the required rate of return, and the computer finds the value for NPV for us. In our case right now, it's 4 million, right? So that's calculating NPV. Of course, if we choose a higher rate of return, NPV is going to be negative. NPV is going to be lower, as with 7, NPV is going to be negative. But with IRR, we basically actually, you know, or with IRR over here, we are looking at the same NPV profile. We are looking at the same NPV profile. And what we're doing is we make NPV equal to 0. As you see for IRR, we actually make NPV equal to 0. Instead of this side, we have 0 here, and find the appropriate return to make NPV 0. Here we find where NPV is equal to 0. NPV is 0 at this horizontal line. So NPV is 0 over here at the rate, at the internal rate of return. I mean, my profile, of course, is not really correct. It probably should be something like that, because it's 0 at 3.18. Internal rate of return is 3.18. So if I were to draw this NPV profile correctly, it would look something more like that. 3.18, maybe something like that. NPV is at 0 when the rate is 3.18. So move this here. Okay? So that's the main idea of internal rate of return. Calculations of IRR, just hit equals, type IRR, open the brackets, and put all the numbers there from starting from the very original cash flow, which is let's say the costs, up to everything. Hit enter. That's all. Very, very easy. Okay. So that's IRR. Very, very easy. But sometimes, even though IRR and NPV are kind of different sides of the same coin, sometimes they can conflict a little bit. They can conflict a little bit. They don't conflict on whether they should accept or reject the project. But NPV versus IRR conflict in different size projects. That's for ranking of projects. So NPV and IRR, they don't conflict in terms of accepting or rejecting the project. If NPV says reject, IRR is going to say reject as well, and vice versa. But if I'm trying to rank the projects, let's say I have 2 or 3 places for my factory: Japan, Taiwan, Vietnam, and they're all pretty good projects. And I'm trying to choose the best because I don't have money for all 3 projects. Then there is a potential for some conflict between NPV and IRR. They don't have to conflict, but they may conflict. So you really need to understand this difference. So let's have a couple of projects, right? Let's say project A, and let's say project B. Maybe we could even separate them too. Okay, say an 8-year project, minus $1,000, let's say, giving us 220, 250, 300, and 300. Say like that. Negative 1,800,000, and giving us 360,000 back every year, for example, right? Let's calculate IRR for both of these projects. IRR equals, so equals IRR, open the brackets, and just enter the numbers. Bam. Woohoo! That sounds great. That's like 21.6%. Great, great, great. Let's find the IRR for this project. Equals IRR, open the brackets, put the numbers there. It's only 12%, even less. Ha ha ha. So bad. Let's say our required rate of return, for example, just to make it simple, for both of the projects, the required rate of return is only like, let's say, 5%. So both projects are acceptable, but I can't make both. Let's say, for whatever reason, I can't make both. Okay. I don't have time to implement both projects. Which one should I choose? According to IRR, I should choose project A because I'm going to make 22%, nearly 22% return. Sounds much better than under 12% return. But let's have a look at NPV, what NPV says. NPV equals NPV, open the brackets, all the values starting from year one, and by hand we add the original, then the computer complains, yes, that's because I forgot to enter the rates. The rates requirement is, what was it, 5% we said, right? 0.05, comma, there it is. So with project A, I'm gonna earn over $800. Okay. How about project B? Equals NPV, open the NPV, open the brackets, the rate, the positive values. Again, I forgot the rate, 0.05, comma, close the brackets, and add the original cash flow by hand. Okay, that actually looks better, you see? In the project B, what I earn is $500,000. With project A, what I earn is $800. $800. And just $500,000. I think I prefer $500,000. But if you look at IRR, it's only 12% versus the IRR of 22% for project A. So the trick here is of course in the size of the project. It's much better to earn 12% of 1.8 million rather than earn 22%, oh my god, so much, of just $1,000. Okay, so sometimes these two, what I mean by these two, I mean NPV and IRR, they can conflict on the ranking of the projects. Okay, sometimes other criteria can conflict as well. So let's review what we've learned so far. We've seen NPV, we've seen payback period, we've seen average accounting return, and we've seen internal rate of return. So the last topic we've looked at is the conflict between NPV and internal rate of return, but others might conflict as well. So with any conflict, NPV always wins because it actually shows you values that the project will give you. Let's have a few questions about the IRR. Okay, does it, for example, take into account the risk levels of the project? How do you guys think? Does the criteria of IRR take into account the risk level of the projects in accepting or rejecting the projects? And here we do take into account the risk because we compare the IRR with the required rate of return, and the required rate of return depends on the risk level. The advantage is it's very easy to understand. It basically shows me that the rates, the percentages, profitability that I'm earning on this project. That's all. Okay. And the good things is, yes, it does take into account all cash flows. It takes into account time value of money, and does look at some level of risk through the required rate of return as well. Okay. Of course, there are some disadvantages. Sometimes ranking the projects is conflicting with NPV. And the main disadvantage here is sometimes it just doesn't work. It produces multiple answers. So that brings us to the next subtopic. Okay, when can IRR produce multiple answers so it doesn't really work, and what can we do about that? So this NPV profile is a straight line if the cash flow changes sign only once. Like this. Over here, cash flow changes sign only once, from negative to positive. After that, we just have positive numbers. One change, everything is very easy. IRR works, NPV works, everything works. NPV profile is just a straight line. But when cash flow changes sign 2 times, something like that, for example, let's make some numbers bigger here because the positive cash flows are not enough. The NPV profile is going to look like this. In this case, NPV profile is going to look like this. So if rate is 0, meaning all the dollars are the same, future dollars and today's dollars, NPV is going to be negative, as you see, -1. If the rate is very, very high, if the rate is very, very high, very, very high, not 7%, 11%, 20%, 38%, whatever, then it means that very near dollars are important, everything else is just not important. We just almost don't count it. So very near dollars are important. Again, in that case, NPV, as you see, is negative, right? NPV is going to be negative with very high rates. NPV is only going to be positive if the rates are somewhere in the middle. The rates are high enough to make these future dollars are kind of not really important. That's where we have the cost. So this is not going to be an important cost. But it's not so high to make the middle dollars unimportant. So they are still bigger than the negative $10 cash flow at the beginning. So we have a positive NPV in total. So in this case, if we look at IRR, IRR is the point where NPV profile hits the x-axis. In this case, there are 2 points where NPV profile hits the x-axis. Then what is IRR? So this project is going to give me what return? This much return or this much return? The answer just doesn't make sense. How can the same project give me 2 different returns? So how much money I'm actually making? Tell me. Not how much money, the NPV will tell me how much money I'm actually making, but what's the percentage gain from this project? Okay, so the calculations are kind of like where's the sense in this? In that case, IRR doesn't work. So what we're going to do is use another criteria, which is called modified internal rate of return, modified IRR.